One of Rover Maritime's largest port projects is the northern extension of the Port of Valencia. The project involves the construction of new and important exterior protection works to create a new basin to the northwest of the existing main breakwater. The aim is to provide the port with new terminals, a new harbour entrance, and an independent channel, which will improve maritime access, increase capacity, and reduce current existing environmental and security risks. The contract budget is more than €193 million, with a maximum completion time of 40 months. The works involve the undertaking of the following activities. The temporary works facilities area. This is to keep the loading berth sheltered from storms, to place the stockpiles and the concrete block fabrication plant, as well as other auxiliary services. It covers a surface area of 30 hectares of reclaimed land, made possible by the dumping of quarry-run materials, and protected on its sea face by 2 tons of rock filter layer and 20-ton blocks armour. An arm of the breakwater is extended from the land to shelter the temporary berth of the loading barges, as previously mentioned. The construction of the outer breakwater of 3,450 metres in length is made of 2 alignments, with a 90-degree angle in between. The first alignment, of more than 2 kilometres length, begins at the northern head of the America's Cup breakwater, while the second, of more than 1,300 metres in length, is placed 20 degrees to the northeast. Alignment 1A is a rubble mound type, including a concrete mass shelter wall of 12 metres above sea level and an exterior armour of blocks of 20 and 30 tonnes, placed over an interior riprap rock layer of 2 and 3.5 tonnes and a core of quarry run. Alignment 1B is a vertical type with 23 caissons of 49.5 metres in length, 21.75 metres in beam and 18 metres in depth. From a previously dredged trench in the seabed, the foundations reach up to 21 metres below sea level, with a rubble mound bedding layer guarded by protective blocks on the caisson foundation. The concrete shelter wall is 13 metres above sea level, and the backfill on the platform is 3 metres above sea level. Alignment 2A is a vertical type with 16 caissons of 50.6 metres in length, 26.1 metres in beam and 20 metres in depth. It is a similar structure to the previous one, but founded deeper, in a dredged trench up to 21 metres below sea level, and achieving a final top quay surface which is 5 metres wider. And finally, Alignment 2B is a mixed type. It is basically formed along the previously mentioned vertical breakwater, in the last 9 caissons, which are protected on the sea-facing side with a rubble mound breakwater, including an armour of 45-ton blocks. Lastly, the third major activity is the construction of a secondary rubble mound breakwater of almost 1,100 metres and 2 alignments with approximate angles of 110 degrees between them. The works begin with the construction of the closing breakwater of the facilities area and then the rubble mound breakwater. The enclosure is created by filling it with the material dredged from the breakwater trenches using a trailer suction hopper dredger. The deeper sections of the breakwater were completed with a protection layer of quarry run of up to 4 metres below sea level in the slope of the seaside. The aim is to avoid the risk of damage caused by bad weather conditions and to secure the direct dumping of trucks up to the crest. This also enables the traffic of trucks up to the front line, which are restricted by the 12-metre wide crane. The crane moves forward along the breakwater, placing the rock filter layer and the protection blocks in the armour. After dredging the trenches of the vertical breakwaters, the area is filled with a rubble mound bedding layer placed with maritime equipment. At the same time, the caissons in the mixed tight breakwater caissons are sunk into its final position, followed by those caissons of the vertical breakwater from alignment 1B and those of the vertical breakwater from alignment 2A. Following this method of construction for the vertical breakwater, the caissons which form them are mainly made at the Rover Maritime floating dock facilities at the port of Sagunto. The bedding layer is levelled along the breakwater, and once the caissons are sunk, their inner cells are filled with the trailing suction hopper dredger, and the joints between the caissons and covers above them are completed with the specific maritime equipment. With the completion of the concrete shelter wall, the final sections of the sloping breakwater are achieved.